Okay, this particular problem is one that we're going to use a little bit more resources. We're going to use one of our bigger kinematics equations. So a human-powered submarine is designed, and it reaches a max speed of 3.06 meters per second. We want to know when it goes from rest and accelerates 0.8, what and it gets to the max speed. There's two parts to it. How long did it take, and what distance did it actually travel? So there's two parts to this problem. First off, let's define the direction. So let's say that the positive direction is just the direction of the sub. Easy. Right, now let's get our information. So first off, we're told that the max speed is 3.06. So from the problem itself, it's going to reach the maximum speed, and we want to know how long it'll take to get from 0 to its maximum speed. So from 0 to its maximum speed. So we know that, let's put yellow, our u, which is our initial velocity, we know that as 0 meters per second. And then we know that our final velocity, v, okay, remember those notations, our final velocity, v, is 3.06 meters per second. We're also given an acceleration here, so let's do acceleration in green. So we're given our acceleration, and that is 0.80, that 8 is horrible, isn't it? 800 meters per second. And we want to, for the first problem, we want to, so let's do the first problem. We want to find out what the time is. So t equals, we don't know, in seconds. Excellent. So here you've got a set of kinematics equations. So the best one, if you want, you can pause this video right now and have a look at your kinematics equations and find out which one actually best suits. Okay. Let's have a look. So the best one that actually suits, because we have u, we have v, we have a, and we need t, so the best one is v equals u plus a t. And this one's actually quite good, because our u term here is 0, so that's not actually going to be even affected. It's not even going to affect how this increases. And then this is quite intuitive here. The final velocity will just be, because remember, acceleration is how much it speeds up every second, so it's just how much it speeds up every second. So let us plug in those values. So our v value, so do in orange, is 3.06 meters per second, and that is equal to our u value, 0 meters per second, plus what's our acceleration? Great. Plus our acceleration of 0.800 meters per second multiplied by t. So we want to know t. And here is just simple manipulation of our equation here. Our u term we can ignore, because then 0. So our whole term now becomes 3.06 meters per second equals 0.8 meters per second multiplied by time. So in order to get time, we need to rearrange it. So in order to get time, okay, we have to divide both sides by 0.8 meters per second. So we have, to get time, it's 3.06, and I'm going to put the values, the units on that side, and divide that by our acceleration, which is 0.800, and here it's meters per second, and that will give you, in this particular context here, we have like terms here, we have double of that, so really it's just that gets cancelled out and that becomes a 1. So it should be, and this like term also gets cancelled out, so the meters gets cancelled out, the second to the -1 gets taken away, so it's second to the -1 here, so that second to the -1 comes over the top, and it's just 3.06 divided by 0.8, which gives you, let's have a look at my values that I found. It should be 3.825 seconds. Okay, now I might have to scroll down a little bit to follow through. So to the second part. So part 2. Let's have a look at part 2. Don't want that. You want purple. Okay. So, part 2. From the top, we have just figured out. So we have all this information here. We have U, we have V, we have A, and we've just figured out T. So at this point in time, we actually, what are we asked for? We want to find out how far it actually went. What's the distance that it traveled? So we want to figure out, and we'll put it in blue. Let's put in blue. We want to figure out displacement, and it's going to be meters. And so if you have a look at the kinematics equations that you actually will need, you will need S equals ut plus half at squared. And here we actually have all these terms. This particular first term, if I plug it in, it actually is 0 meters per second multiplied by our time, which is 3.825 seconds, which equals 0. You're adding that to half times our acceleration, it's in green, 0.8. And I'm just going to omit for now. I'm going to omit these 2 decimal points just to save a bit of space. 0.8 times our time, put that in magenta, our time is 3.825 squared. So in order to get it, you just do all those values and it should blue. Oops, not only. I'm going to erase this bit here. Let's put that in blue. Equals, in the end, it equals 5.85 meters. Okay, so your final answer is 5.85 meters, and I hope that was helpful.